Assalamu alaikum wa rahmatullahi wa barakatuh. This is the second experiment, the DC series generator. This is the practical session. We will start with the synchronous motor, which is this one, the synchronous motor. This drawings is belong to the synchronous motor. We will start connection by doing the same connection that we did in the previous experiment, the separately excited. Here I will remove the meters, so I will start from 1 to 1 of the field coil of the stator directly, so from 1 to 1, ignoring the emitter. So we will have 1 to 1, 2 to 2, 3 to 3. This is the power supply, and this is the synchronous motor. Then I will short this one, shorted. Then the 120 fixed voltage, 120 fixed, not variable, fixed power supply will be going directly to the exciter 7, 8. So from 8 to 7 and from N to 8. So this connection will start the motor, will make the motor rotate. So when I start, the motor will rotate. This is what we need. This is what we need to drive this one, which is our primary component, which is the DC motor generator or the DC generator. This is the circuit diagram of the series DC generator. We were having the armature connected in series with the stator, so it's not separate like the previous experiment. The armature connected in series with the stator coil. So from 2 to 4, from 2 of the rotor to 4 of the stator series coil. This is the DC motor generator. So from 2 of the armature to 4 of the series coil, series field. Then from 3 to the minus emitter, from 3 to minus emitter. Then from positive emitter to our load. Here we have 3 sets of resistive load. We have 1, 2, 3. So we short them from the upper part and we short them from the lower part. Then we take wire from here, from the upper part to the upper part, and from here to here. Then from the lower part to the lower part, then from here to here. Okay? From positive emitter to the upper part of the load, from positive emitter to any upper part, here or even here, doesn't matter. It should be the upper part. So here, then from the lower part, because we connect them all from the lower part of the resistor to one of the armature. One of the armature from the lower part to 1. From the lower part to 1. Now, this is the circuit diagram. In this table, we have the first column, which is infinity. So all the switches are off, all of them off. Then we will start by measuring the armature current, which is this one, EA, which is this one, the generated voltage. We measure it by the voltmeter connected in EA. So the minus of the voltmeter going to 1, minus of the voltmeter going to 1, and the positive of the voltmeter going to the positive of the ammeter. The positive of the voltmeter is going to the positive side of the ammeter. In this circuit, the field current, which is responsible for the magnetic field, is equal to IA is equal to IL. So if all the switches are closed, that means an open circuit, so IL is not existed. So what I will have is just the generated voltage. Okay, the generated voltage, I will just switch this one to read the generated voltage, which is 10 volts, because I place it here at 20, 10 volts. Zero, because no load, off, all of them off. 10. Now, the 44.3 ohm, how can I get that? Since I have 3 resistive modules, I will multiply it by 3. So 44.3 multiply 3 will get me 132.9. 132.9. So the closest one is this one, 600, all of them, none. 600, all of them, none. So the load current right now is 0.2. And the generated voltage is 12.5. And that's it. I will continue. I will multiply each number by 3, then take the number and find it here, and continue doing the experiment. Once IL, if you increase R load, that means IL will increase, IA will increase, IF will increase. If we increase IF, that means flux will be increased, then the generated voltage will be more. That's why whenever you turn on the load, the generated voltage will be more. Thank you so much.